2300 successful pairs of spells and potions. So for this problem, we are getting two arrays, spells and potions. And for the spells, it's gonna be just random integers, and for the potions, yeah, it's gonna be also the random integers. So the length of them gonna be n and m, and where spells I represents the strength of the i's spell, and potions j represents the strength of the j's potion. So that doesn't matter. So inside it is always positive integers, so it doesn't matter. So what are we gonna do? So we are also giving an integer success. A spell and potion pair is considered successful if the product of their stress is at least a success. So what does that mean? So let's just check the first example. So for example, for the this spell, for example, this integer 5. Yeah, because 5 times 1, it is 5. It is a less than success, so we will not count it. And after that, 2, 3, 4, and 5, we're going to count it, because 2 times 5 is going to be 10. 10 is more than 7, so we're going to count it. So we're going to return a 4. And similarly for this one, because 1 times 1, 2, 3, 4, 5, they are all less than 7, so we're going to return a 0. And for the final one, it's going to be 3, so we're going to choose a 3. 3 times 3 going to more than 7, and after that, we're going to have a 4 and 5. So finally, we're going to return a 3. Yeah, so this is exactly what we are going to calculate, because we're going to return an integer array pairs of length n, where pairs I is the number of potions that will form a successful pair with the i's spell. Yeah. So according to the description, it is very straightforward. We can directly solve it by using the binary search. Yeah. So we're gonna check each of the spell. So for example, for n inside the spell, and let's just prepare some variables. Before that, let's just sort the array. So yeah, the potions we need to sort it because we're gonna use the binary search. And we're gonna prepare an empty pairs array. Yeah, because definitely we're gonna prepare all those integers inside the pairs array. Yeah. So for each of the integers inside of the spell, we're gonna use a bisect left to check where it is. Yeah. So inside we're gonna use the potions array, and definitely we're gonna need this spell. Yeah. So this spell needs to times this integer inside of the potion, and the final result is going to be more than 7. So if it is like that, so we're going to use the final success. So the final success is going to divide it by this number. So for example, 7 going to divide it by this 5, and we're going to check it. Yeah. So for the calculation, we're going to use a seal of the success and divided by the spell. It's going to be this number n. So for example, if this is 5 and this is 7, so 7 divided by 5, it's going to be 1.4, but we need to use a seal. We need to turn it into an integer, so it's going to be 2. Yeah. So if it is a 2, so it means the first one is not okay, so it's going to be the second one. So here we're going to get an index, and after that we're going to check how many numbers. So after that index, it's going to be 4 numbers. So it's going to be length of the potions array minus the I index. Yeah. So we need to append it inside. So it's going to be the length of the potions array minus this I. So finally, we just need to return the pairs. Yeah. Now let me just run it and submit it to check if it works. Yeah. Yeah, as you can see, it works and it's pretty fast. So this is only for you are really familiar with what is binary search and how to write the bisect left. Yeah. So maybe you're gonna ask to write the bisect left. So let's just write the function of bisect left. Yeah. So inside, let's just put yeah, maybe nums or the target. Yeah. So we're gonna write a bisect left. So L are gonna be 0, length of the nums minus 1. Yeah, we just write a binary search. So this is the lower bound, so we're going to call it bisect left, and here going to be L plus R divided by 2. So if nums m is less than target, so we're gonna update the L border. Otherwise, we're gonna update the R border, and finally, we're gonna return the L border. Yeah. Now we're gonna directly use this bisect left to check if our binary search is okay or not. As you can see, it works. If you don't believe it, let's just use bisect left 2 or bisect left 2. Yeah. Yeah, we just write this method basically. But in Python, we can directly use it. Yeah. As you can see, it also works. Yeah. I think that's all about it. Thanks for watching. See you next time.